What is going on, guys? My name is Cooper. Welcome back to another Java tutorial. Today we're going to talk a little bit about different variable types, and more specifically we're going to talk about primitive data types and strings. Strings are not a primitive data type, but that's okay. We're still gonna talk about it, and because they're important. So first, data type. And data types, they're useful because they store data, and different types of data need different types of storage. And for example, let's say you want to write a program and you're gonna ask somebody, what's your age? Okay, you probably want to store their age because you're probably going to do something with it later. Maybe that's to determine if they're old enough to drink, okay? Or to drive, or to, be in the 9th grade. I don't know, whatever. And so you want to store their age, but you can't just type age and then set it, like I'm 19. So you can't just say age is 19. And again, this is a statement, so remember your semicolon. It's going to say, well, I can't find the symbol age. I don't know what that is. And age is a number. In this case, it's 19. And so what you want is an integer, or an int, more specifically. And that's what ints do. They store whole numbers, not decimals. Int, by default, is a 32-bit integer, which means that as far as binary is concerned, it can store a 32-bit number, which I believe, actually look this up, I believe the maximum value for a 32-bit number is, let's see if I remember, it should be 2, 1, 4, 7, 4, 8, 3, 6, 4, 7, right? That should be the maximum value of a 32-bit integer. And the minimum value is actually this same number, except negative, and then you add 1. And so, yeah, and there's a reason for this, and that's because computers, they start counting at 0. They don't start counting at 1 like we do. And so when you think about, if you have a number line, if you have this all the way up to this number, you actually have this number right here twice. The only difference is this positive range includes a 0. So if you were to add a 1, if you take 0, it's like if we were to shorten this range, let's say you have a 7 to like -8. Or let's say even this be less than that. Let's say a -2, and here you have 1. Okay, so what are all the positive values? Well, in this case, it's 0 and 1. What are all the negative values? -2, -1. So as you can see, there are 2 values here, and there are 2 values here. So the maximum positive is basically take the maximum positive value, add 1, stick a negative sign in front of it, and that is your minimum value. And that's wise, because they start counting at 0. So that's what an integer is. Yeah, it's just for any whole numbers. You can see if I add, let's say I wanted to say, I'm 19 and a half. Well, this is going to say, no, you can't do that. You can only store whole numbers into an int. And you'll notice if it says incompatible types, possible lossy conversion from double to int. So what is a double? Well, that is actually our next data type we're going to talk about. And a double, let's say you want to say, total. Let's say you're buying something online, and your total is, $15.26, right? Well, this is what double does, is it stores a decimal place. And a double is actually a little bit bigger than an int. I'm tempted to say 64 bits, but I'm not even 100% sure, to be honest with you guys. It's not too big of an issue. It's a huge number. You really don't have to worry about it. Everything's exponential, so if the maximum 32-bit integer was like 2 trillion, uh, a 64-bit number is, yeah, you guys are fine. Trust me. So, yeah, so that's what a double does, and it stores, yeah, just it stores decimal points. And there's one other type that does store a decimal point, and that's called a float. And say we name this total 2 equals, I don't know, 1629. All right, and this also stores it. But you know, why is it red, right? Like, they both store decimal points, so what's wrong with it? And the reason for that is because right now you need to add an F to the end of this, because what happens is when you're doing calculations, you can mix these data types, and you might have loss of data. For example, if you have a double, which can store a bigger number than an integer, and you were to convert a double, and also an integer can't store a decimal. So if you were to convert this to an integer, right, it would just hack off the decimal. Oh, shit. It would just hack off the decimal. It would just get rid of it. So if you were to convert this to an integer, it would just say, oh, 15. Well, when you think about, you know, okay, the 15 value, you lost the 0.26. That's why it was coming up with the error of possible lossy conversion. Well, if a double is bigger than a float, and they both store the same value, then does it treat this as a double, or does it treat this as a float? And it doesn't know unless you put an F here. So yeah, and I believe you could also put a D there, because a D is stands for double, but you only need to put it there if it's so big. It'll come up with an error and yell at you. Like, I believe if we just keep adding numbers here. What is this? Yeah, I don't know. But yeah, so that's kind of the general layout of it, I guess. I guess, if you will. So you need to put an F at the end of floats. So, yeah. Okay, so let's talk about next primitive data type. We're going to talk about a char or char. Some people say char, some people say char. I don't know. It doesn't really matter. Personally, I say char because it's short for a character. But, like, I don't know, my teachers and stuff, they all say char. So I don't know. Call it what you want. It's not super important. But basically, it's just a character. Like I said, that's what it stands for. So if we were to say, you know, first letter of, you know, of my name, let's say, right? Well, the first letter of my name is Cooper, is C. That's it. That's all it stores. And this can be lowercase, it can be uppercase, it could also be a symbol. You could store that. You could store a number. It's just a character. It doesn't necessarily mean letter. It just means a character. And you notice that we'll put this, we don't just write one. You put it into the single I guess I don't know what to call single quotes, I guess. Yeah, so that's how you write a char or char, whichever you prefer. So yeah. Moving on to our next primitive data type, we have a Boolean. Now, Boolean, say, did I eat, you know, breakfast? Booleans can be true or false. That's it. There is no maybe, there is no sentences, no numbers, it's just true or false. They're actually extremely useful later, and you'll most definitely be using them quite a bit. So definitely one to know, especially when you get into looping and comparing statements and stuff like that. So definitely a good one to know. So yeah, Boolean is true or false. Okay, guys. So our next primitive type here. I know I'm kind of jumping around. I do apologize about that, but these are all good to memorize. So ultimately, it doesn't really matter the order. You guys should eventually know all of them. You will use them commonly enough. Your most common ones are going to be doubles and ints, and booleans and strings. Those will be your most common, but you'll use all of them. You need to know about all of them. But our next one here is a byte. It is basically just like an integer, except it's only 8 bits, so it's very small. So this actually would probably be more appropriate for age, because when you think about, the maximum integer was what, like 2 trillion something, right? Like nobody's 2 trillion years old, so storing somebody's age would probably be more appropriate to store in a byte because it's more efficient on memory. You won't ever need to store somebody's name up to the maximum integer. And that's more why we have these data types, isn't so much to say, an int and a byte do the same thing, a double and a float do the same thing, they're just different sizes. Well, that's why, because when you have, a massive program, saving 16 bits, 24 bits, whatever, here and there, adds up over time, and you can really reduce the size of your program by doing that, because even though this is not the maximum integer, it sets aside enough memory in your computer to hold the maximum integer. So this 19 doesn't take up any more memory than if I were to type that. There's no difference in the amount of memory it takes up in computer, because I declared how much I want set aside right here. And so that's kind of the difference between int and byte. And I guess that kind of leads us to our next one, which is a short. And a short is 16 bits. So, you could say, I don't know, number of words I know. And I'm extremely smart, so I know like that many. I don't even know how many that is. It's not even. Yeah, it's there we go. it was more than the maximum number that a short could hold. So yeah, I guess I could probably add these in. These are just comments doing 2 backslashes. So this is 32 bits. A double is 64 bits. A float is 32 bits. A byte is 8 bits. A short is 16 bits. A char is actually stored as 16 bits, although, like I said, it ultimately doesn't really matter too much. But yeah, and then a boolean is just a 1-bit number, because internally, I believe it's just stored as either just a 0 or 1, true or false. That's it. So booleans are actually very, very memory efficient. Yeah, so we're almost done, guys. I actually believe I only have one more to go over before we get to strings, and that's called a long, which is basically just double the size of an integer. So some long number equals whatever, even is that integer too large? Okay, so there we can just kind of reduce the size of it, and this is a 64-bit number. So these are all your primitive data types and what they're used for. You guys might be wondering, like, well, what happens if for whatever reason I need to store a number that's bigger than 64 bits? And we'll get to that later, because there's a way to do it, but it's not any program you guys are writing at this point, you shouldn't ever need to. So just worry about these for now. Yeah, so just kind of summarized, you have a byte, which is an 8-bit whole number. You have a age, or integer, which we named age, but an int, which is 32 bits. And I should also say an int is different than a integer, and we will get to that later. Those exist, they're different, not the same thing, just know that. An int, which is a 32-bit whole number. A long, which is a 64-bit whole number. We have a float, which is a 32-bit decimal, it can hold decimals, so floating point number. A double, which is a 64-bit decimal number, it can hold decimals. We also have the short, which is a 16-bit whole number. A char or char, which is just a single character. It takes up 16 bits. Like I said, characters can be anything, not just letters. You could say that. Doesn't matter. And then we have a boolean, which only takes up 1 bit, and that just stores true or false. So that should be all your primitive types. Now let's move on to something called a string. And a string is, you will use it commonly. A string is basically, if you remember, when we typed in our Hello World program and we put that thing between double quotes, that was a string. And a string is basically just a whole bunch of characters that are lined up, and it's all the characters sandwiched between these double quotes right here. Yeah, so anytime that you want to, get input from a user, you ask them, hey, what's your name? And they type it in. Well, that's going to be a string. It's not going to be a char because it's not just one letter. Now, if you were to say, hey, what's the first letter of your name? Well, okay, now that would probably be a character or char. And in all honesty, you'd probably still store it as a string, just because you guys will see why later. It makes more sense to do it that way. In fact, even if you ask somebody what their name is, you'll probably bring it in as a string and then convert it to an integer. So yeah, that is all your primitive data types, as well as the string, which is not a primitive data type, but it is used so commonly that it might as well be. It's not, and there's a reason for it, and we'll get into that later when we talk about arrays. But yeah, so there you guys go. Those are the primitive data types plus string. Hope you guys enjoyed. Have a great day, and I'll see you all next time.